This problem typically shows up with straight lines. It's found itself in with these, I guess, right before the section on these transformations. So for this, basically, you need to be able to find the slope of this line. You need to be able to write an equation of the line with the slope that you found going to a particular point. The line is y equals negative 3/2 x minus 7. If you compare to y equals mx plus b, slope-intercept form, you will see that the slope of this line is negative 3/2. Happily, it's in slope-intercept form, so just by inspection we can tell that. The equation of the line that's parallel to this would have to have the very same slope, so that's the slope we would use. Any line that's perpendicular to this, do two things. You change the sign of the slope and then take the reciprocal. Or, if you prefer, take the reciprocal and then change the sign. In either case, it's got to be positive m perp. Sometimes I'll use that to denote the perpendicular slope. It's not necessary to use that notation if you'd prefer not to. But the slope of the perpendicular line would be positive 2/3. You want to make sure that these two slopes are opposite in sign and their absolute values are reciprocals of each other. That will ensure that the lines are perpendicular. In both cases, it'll be the point slope form. Y minus y sub 1 equals m times x minus x sub 1. In the b part, it'll be y minus y sub 1 equals m perp, or just call it m again if you prefer. Just put the right number in there. Alex should be okay with it if you substitute and then put each of these in slope-intercept form. So the point is given in each case. The point's 9, 3. So y minus the y-coordinate 3 equals the slope negative 3/2 times x minus the x-coordinate 9. And then just simplify and then ultimately solve it for y. We distribute the negative 3/2 across the parentheses. It's going to be negative 3/2 times x. Negative times negative is a positive. And it looks like a fraction, but I guess it'll be okay. 27/2. We multiply 3/2 by 9, we get 27/2. If we add 3 to the left-hand side and add, well, I don't want to add 3 because I want a common denominator. Well, I do want to add 3, but I want to get a common denominator. Call it 6/2. 6/2, 6 over 2 equals 3. So I'm going to add 6/2 to the right-hand side and get y equals negative 3/2 x plus 33/2. Anybody notice any careless mistakes that I've made? I haven't made any deliberately, but sometimes accidentally.
Could you not just plug those points into the equation with the slope and then solve it out? Or?
It can be done. There is a procedure where you could just say, well, it's got to be of the form y equals negative 3/2 x plus some number b.
Well, I mean, like plug in the points that you're given and then solve for b, and then revert it back to slope.
Exactly. Exactly. It's not a preferred method because to get there it requires solving an equation rather than just substituting into an expression. So there's a bit of awkwardness to it, but as a method, it works. So as far as the finished product is concerned, there's really not going to be an issue. Let's see how it works in this case. We could take the 3 and substitute it for y. Then it's negative 3/2 times 9 plus the unknown y-intercept. We know the slope, we don't know the y-intercept. So we substitute and get 3 equals negative 27/2 plus b. And the arithmetic is basically the same. On the left, we're going to have 6/2, and then we're going to, well, I guess, what should I have done? At that point, I should have called that 3 6/2, and then that way when I add 27/2 to both sides, I get 33/2 equals b, and that means that's our b there. So final answer, y equals negative 3/2 x plus 33/2. I suppose an argument can be made that slightly less time consuming to get there that way. It is a valid method, it's just not the preferred method, particularly if the final answer is going to involve any type of unknowns. It's just better to have a formula that we can substitute into rather than having the burden of solving an equation to get that value. The other part is really the same procedure, except that it's a different slope. So let's see, y minus 3 equals positive 2/3 times x minus 9. A little nicer because 2/3 of 9 is an integer, so we don't have the fractions to deal with. Y minus 3 equals 2/3 x. 2/3 of 9 is 6, so that's going to be minus 6. Add 3 to both sides, and y equals 2/3 x minus 3. If we had lots of time on our hands, it would be great to graph all three of these lines. Look and see that this line and this line both go through the point 93, and this first line that we got is parallel to the original, and the second line that we got is perpendicular to the original, but time is short.